long time. Smoke has been around for 20 years, well, 20 plus years, and I feel over the years we've changed and needed to get away from the smoke and start looking at other issues we've seen in the 20 years we've been doing this, 20 plus years. So, a little background on me for you guys that don't know me. I'm Rick Escalambre. I've been in the industry 51 years. I bought Skyline College in San Bruno, California for 31 years. We had a fleet of 80 OBD2 vehicles. We had 4 dynos, lots of EVAP machines and equipment. We started out with a 4-hour course initially, eventually expanded into a 36-hour course. And you can see in these pictures we were pretty well equipped for everything. And that was only part of the lab. We'd have 10, 11 cars in a shop for a lab on EVAP. We did a lot of outside work. And since I've been retired 10 years, I've stayed involved in helping people with this, and we're going to see a couple of those case studies today. I also developed a course that we use in our California smog update training that about 6,000 California smog check technicians were trained in EVAP through my course, so I'm very proud of it. Feel I bring something to the offer, and this is going to just a small bit of what we have available, and I'll tell you about the next one next month that we're going to follow up with. So, and if you guys want to chime in with questions anytime, don't hesitate. One resource I want to give you, it's a free one. There's no cookies, no advertising. It's my website. It used to be rlescalambre.com. Then I went to .net and really cleaned it up and organized it. It's a work in progress. If you ever do go to my site, take a look at the thing over here. It says new content. Been a little lax lately. It was a busy summer with family stuff, but I'm going to be adding a lot more information on there. And that page is like a TSB page. It'll let you know what I've added since maybe the last time you were in there. But you can see all the topics on the left. And I'll be populating a lot of that as we go along, especially this fall. So if you go in there, please feel free to check in, reach out to me wherever I can improve that, and just another opportunity for information. The cool thing is it's designed for the industry, and it's designed for trainers, techs, and again, no cookies, no advertising, no money involved. What are we going to do in this next hour? Basically, I call it before blowing smoke into an EVAP system, do you know the following? One, be familiar with the type of system you're testing. We're not going to go into details on the different testing, but we're going to give you some fundamentals that you can apply to a lot of systems. What are the typical components used? We're going to briefly on that. It's not a training class of going back to all the steps of each individual component, but it is one that's designed to say, hey, these are some tips you want to remember. What happened to illuminate the mill? Very important. My follow-up next month is we're going to actually be doing, I'm going to do an hour one on running monitor tests to set readiness flags and to verify a repair. Because in California especially, we're going to be going to no incomplete readiness flags starting October 1st. That includes EVAP. So that may open a little can of worms that people are going to need to be aware of, and I think I can give some good insight on that. Hit briefly on the difference between circuit, leak, DTCs, and rationality DTCs. And rationality means basically some of you used to be a drivability tech. Well, now when Nobody 2 came in, supposedly it did everything rationally, but we found out that was contrary to everything. You still need to be a drivability tech. Now, what are the important PIDs to look at when investigating an EVAP concern? I'll show you a case study on that one. It was a very, very expensive person for someone here in California, and the pitfalls that could have been avoided and saved them over almost $4,500. So we'll get into that. Two type systems, briefly on this. Two types of systems out there. 96, 97, there was a non-enhanced. And in California especially, I know the Pacific Coast time, I'm assuming some of you are from the West Coast. We have a lot of the older vehicles out there. And this basically was a system that did not do leak checks. All it did was monitor that the purge was opening and a vacuum was being drawn on the system. Didn't tell you how many vapors flowed. It didn't tell you if it was what the content of it was, just that it opened and closed. And if it was open when it shouldn't have been, it let you know that. Enhanced systems are really where the meat is at. Since 1996, some cars have had it since 96, all since 1998 have had to go to an enhanced system, which basically means they perform leak checks using either vacuum or pressure to monitor the system. And as we know today, some of those systems are when the key is turned off. And that's what can make it longer, not necessarily more difficult, but it can be longer. I break it down into basically 4 systems that are out there. Vacuum decay overlaps into basically almost all of them. It's got to be a setting on his end. So Vacuum Decay is the most common. It overlaps in almost all the systems. Basically use an engine vacuum to pull a large leak, and in many cases on the older cars, small leak test. And we still use that on canister vacuum pressure systems. We still use it on some leak detection systems, and we use it on most of the natural vacuum leak detection systems. Matter of fact, all of those. So, well, vacuum decay is the main one, and that's what we're going to focus on a little later. Canister vacuum fuel tank pressure was used on Hondas and Toyotas. Honda's through about 2006, Toyota up about 2004, roughly in there, and they started coming out with the pump systems. But basically, those were systems that were split systems. They could either test the canister side, the tank side, or in some cases, they could test the whole system as one. Not that difficult, but to test them and really understand them, you had to be able to visualize the system. One of the reasons I'm touching on this briefly is you got to visualize the system to be effective. Leak detection pumps from either pressure or vacuum or current checks. We'll take a look at that a little later. The idea is let a pump do the job. They're still using some pumps lots of pumps out there. And LDP, there's been the key off systems. So, but what we're going to cover today applies to all. And again, the LDP would be with the engine running. And engine off natural vacuum leak basically uses the vacuum decay principles, and at the same time heat and expand the tank, test it after shutdown, and see what goes on. So anyway, let me move on. Just a little chart I put together when I wrote the course years ago. Probably could add millibars and pascals to this, but the idea is this was to give you an idea when you're working with EVAP, what a typical range would be. When you're working with EVAP, it's a very small amount of vacuum or pressure. Your machines typically put out no more than 0.5 inches up PSI. When you're drawn down into a vacuum, you can see on the right here, 10 inches is a very common drawdown, but I've seen some go even higher than that. Especially some of the pump systems will go up in the 20, 25, 30 range, like on Toyotas. The idea is leak checking itself. But this is a little chart that can help you, and I'd recommend if you're getting if you're going to get some kind of smoke machinery you have, a compound gauge is nice, so you can see the pressure in the system, but at the same time, the bottom one over here is on a Honda, and it's in a cool down after shutdown, and I can see right here on this vehicle that the vent solenoid is closed and it's starting to draw a vacuum, so I know this very small leak test is running. So just a little clue when you're buying a machine. As far as with your gauges, this is probably one of the misunderstood ones out there, and on the older scan tools and older cars, you can see it either way. You can still see it on the OEM side either way, but on the global side, we've gone to only absolute pressure. We don't have gauge. And think of gauge as being like fuel trim. Plus is pressure, minus is vacuum. And again, very important. We'll take a look at an example of that here in a minute. The other side is basically 0 to atmospheric or beyond atmospheric. So we start at absolute 0. And we'll see that on the next slide here. So this I captured off of a Toyota with a pump system. On the left-hand side, you see gauges at 0, which means we're at atmospheric pressure. Typically, millimeters of mercury at absolute would be 762. But where this vehicle was being tested, the ambient temperature, the barometric pressure, that could lower that number a little bit. Well, I know if we're somewhere between 757 and 762, we're pretty close to sea level. So if you notice on this particular car, it says 0 and 757. That's our starting point. If you look on the right-hand side of the same side, where it's being drawn down into a vacuum, you basically take that 19 plus whatever it is and 737, you've got your total of 757. So you are drawing a vacuum on the system, but it is important, again, that we know that this is basically an absolute pressure. We're not working plus or minus. We're strictly going from the highest number and taking away from it. So when you're working on these older systems, if they show millimeters of mercury, 762 sea level, right conditions would be the absolute number for you to work with. Purge solenoid real quick. Normally closed. It's duty cycled. Hasn't changed much. I think there was only one solenoid that Nissan ever used back in the mid-90s, right in the early start of OBD2, where it was normally open and they closed it. Everybody else is closed and duty cycled. Vacuum decay, basically used to pull a vacuum on it. But the note here, the most important thing is a faulty purge can set a large leak DTC if it does not fully open. That's really important on your checklist of gross leak codes. The question is the pintle moving? Is it fully open? Is it plugged with charcoal? These are things we need to consider. We're going to look at one case study that involves all of that. Japanese systems used to call them the vacuum switching valves, VSV, just another terminology for the valve in the middle of the car. But they'd also call the purge VSV, the canister close, vacuum switching valve. But vacuum switching valve typically was in the middle of the car, which we're going to take a look at that one real quick. Vent solenoid, the big coin there is back door, front door purge. Normally open. There's only one case that I can think, excuse me, where they're normally closed. And that was on some vehicles, Chrysler vehicles. They had NVLD, and they left it closed, and then they energized it when the car was running, so that when they shut the car off and it cooled down, the system was sealed, and they could see it draw into a vacuum and get a reading if there was no small leak. Remember, the only time this thing is open, oh good, Tom's in. The only time this thing is closed is when the monitor test runs, which means depending on where you're from, this thing could sit around all winter. In my first webinar today, I had someone from Alaska and I had someone from Pennsylvania. You know what happens in the winter there. This thing is never operated. Some of them now, at least when they operate, is after a fill up, they'll exercise them to check to see that the cap is not off. But very important to know that this is a lazy solenoid, and because of it, it can get stuck, get dirt and water in it, especially the older ones because of the placement of them. And one other thing you used to get was a lot of cobwebs because that canister draws heat and it draws in the bugs, and that's where they create their cobwebs. If you're going to test this, exercise it, exercise it, exercise it. And I prefer to see it blowing smoke through it if you have to, so you know it positively turns off. The ball drops to zero at that point, or there's no leak on that system. You plug it off and just test it by itself. Very, very important. Don't just click it a few times. Run it multiple times. And one of the problems with the older ones, they a lot of relocation kits, was fresh air being drawn in, but at the same time it could be water and almost anything else. I remember some Nissan trucks where it was sitting right there in the back like that, and if you put the boat in the water, you could suck that in, and then you basically turn that canister to mud. So little tips to think about. Vacuum switching valve, we're going to look at a case study on this one later. A lot of Toyotas still out there that have the split systems. Those things last a long time. And I'll show you a case study of how you can diagnose this quickly without even getting underneath the car to diagnose it. The only reason I had to get under the car with this one was to replace it. It took me longer to replace it because the screw is so hard to get at. It's so small than it did to diagnose it. The main thing on this one is this is normally closed. Honda used it. Toyota used it a lot. There are a lot of cars out there still with this system. So understanding how this works. Unfortunately, we're not going into the full operation of the system. Might do that. We'll be doing that in the next month on the tech tip when I do EVAP monitors. We're going to have to explain the system a little bit and how the monitor runs and what's going on. When you're working with EVAP, absolutely, you should do this on any car, really, anytime you're working on it. Verify your critical PIDs right up front. This happens to be a global OBD2 car. It happens to be a CAN car, which means it's 2008 or newer. I've got my ambient air, I got my intake air, and I got my coolant temp. I got good calibration there. I checked this car against ambient temperature. We were right in that range. None of them are skewed. For a lot of your EVAP systems, we need that temperature within the 40 to 95 degree range to run the EVAP monitor test. It's not all vehicles, but that's a calibration check that tells me I got a good starting point. Barometric pressure, absolutely got to check that every time you do the car. If this thing gets skewed, it doesn't set a code, and it can shut down the monitors, and it can cause drivability issues. Fuel level, you know it's a CAN car because the fuel level is there. Big thing there is, some of the vehicles with the rheostat for the fuel level being a problem. Something to look at. Is it noisy? Is it not reporting all the time? That could be a blocker there. Warm-up cycles, I put that on there just for a reason. If you get a car into a shop, take a look at this on the global side because it lets you know how recently someone's been in there. The car that comes in with no face on the brake rotor, and it just happened yesterday, it's been going on for months. This tells you that this vehicle has been recently cleared, so somebody cleared it before you got the car. I think that's important. Control module voltage, absolutely, because your key-off systems rely on good battery integrity, and if the state of charge in that battery is not good enough to hold that test after shutdown, it's going to void the key-off system. So very, very important that you make sure you got a good quality battery in that car. And the last one on here is my EVAP system pressure. The problem with global OBD2, when we went to CAN, they use pascals. It's a very, very small number. I wish they had used inches of water, millimeter of mercury, kPa. We're more familiar with that. But I'm going to show you where you need to be aware of this and how you could get fooled by this if you don't understand it. Now, if you go over to the OE side of the scanner, they can use any value they want. I see PSI. I see inches of water. I see millimeters of mercury, millibars. So they can do whatever they want. The one I despise is PSI. I'd rather see one of those small numbers because it's a better reflection of what it's seeing as far as a vacuum. Okay, so that's something to check before you ever think about running monitor tests, or you're going to do anything with the EVAP system where you're going to try and run a monitor test. Now, this particular car, a little bit different, but its temperatures are out of range, and people would normally think that, oh, with that spread on the coolant and air temp, it's not going to run its EVAP test. Most cases with vacuum decay systems, the older systems, it won't. Next month we'll talk about Nissan and what you want to look for in Nissan. I can run a Nissan all day long regardless of temperature. It's all what's happening with the temperature in the tank in this example. A lot of your key-off systems, your pump systems, don't care about this temperature. They want to see driven time, they want to see 5-hour shutdown time, then they want to see pump time. So not always so critical, but things you want to check. We do get commanded purge now on the global side, which we never did, which is nice to know. There's your module voltage. There's your tank pressure again. I'll just give you an example here how it can vary from global to CAN. If you look at the top one, I get purge, same as normal. I get a duty cycle. I get on this Nissan, I get a fuel tank temperature. That's critical to run an EVAP monitor on a Nissan. I get my fuel level and voltage. I can graph that. I can look at it. I get my fuel pressure sensor in voltage. And I'm going to apply this to a study later so you can see why you need to be aware of this. And at the bottom, if you take a look at global, I'm getting my fuel level. I do get my commanded purge, but I get my vapor pressure in a very generic Pascal reading. And again, we'll look at that on a car as we go through this a little bit later. I want to run it right into a case study to show you how critical it is to check this stuff and how not being aware of this can cost the customer a boatload of money. A good buddy of mine I played ball with in college 5 decades ago. I hate to say it's not been that long, but it's been 5 decades ago. Then he used to live near me here in the East Bay outside of San Francisco. They were friends and everything, and they moved to the foothills of Lake Tahoe, and he calls me up and says, hey, Rick, my wife's car got an exemption for the last smog because it won't run monitor tests anymore, and I've had it to a bunch of shops. It's cost me over $4,400. We're going to be due for another smog. They're not going to give me another exemption. They even recommended I replace 2 cats, and one of which he did. And if this was in a Mode 6 class, I would tell you, in the end, he didn't need either of them. But the California referee was giving him an exemption one time, but he had to come up with a new one. So I said, hey, Butch, I said, I'm an hour and a half from you down in the Bay Area. You know where I live. You want to drive down. So he drove down. We had this thing diagnosed in about 10 minutes, 15 minutes after the greetings in the bowl and hooking the scanner up, and I'll take you through that process we did. Now keep in mind, this was a pre-CAN car, so the information, you had to search it out. It wasn't just on one screen like I've been showing you. I had to go from global to OE. So when I got this vehicle, I verified what he was saying was correct. Everything but EGR was incomplete. And he needed those, obviously, to get this car smocked. And that's what he's been dealing with for the longest time. So while I was on the global side, I did look at some values. I did look at coolant. I did look at intake air and barometric pressure, make sure everything was somewhat normal. But if you notice, there's a couple PIDs that are missing here. But I thought, while I'm on this side of the scope, I want to see, what do the O2s look like? So with my Snappy, I grafted it, and I was quite content with what I was seeing here with the throttle and the O2s. So took that off my list. And the reason I show this is what I call reporting component. That's a reporting component, obviously, for the cat. But it's also what we're going to be looking at affects the monitor for the O2s running based on the component we're going to look at. And that can be, that's where the whole problem was. I also want to verify in Mode 6 that there were no misfires. There's one with 327, but that's a history. And there's nothing not enough in there to affect things from running. But I wanted to just eliminate those. So now I'm done with the global side of the scanner. Well, not quite yet. I want to go in and verify a couple Mode 6 things I want to show you that don't get fooled with if you're working on older cars and Mode 6, and especially on Fords and GMs. If you notice here, it says fail. But there's no DTC present. When that happens, totally ignore it. Ignore that reading, failed. They flipped their zeros and ones, they got them wrong. And the other thing you see is here it says it passed. And on those older cars, that's not allowed anymore in CAN cars. It says not complete or it passed. Or complete, I should say. So there's no guessing. So this just showing you the test that was being done here. I pulled it out of the Ford free information. Here's another one. Again, it says it passed, but the value is 0. This test hasn't even run. EVAP tests are not running for a specific reason. So now I'm done on the global side. I already know where I want to go with this because I had a feeling what it was. We moved over to the OE side, and here's what we saw for the fuel tank pressure sensor. And if you're familiar with Ford's, fuel tank pressure sensor normal is about 2.6 volts with the cap off at sea level. And I saw this here, and I thought, oh boy, that would explain it, because if you go into the Ford information, it says to run the O2 monitor as example, you can't have a gross leak code. Well, it didn't say the FTP could be skewed and not run it, but I put the two together and said, you know what, it's got to be the FTP. So to make a point with him, I walked across the street to the neighbor's car. I took him with me, a neighbor's Taurus, same year Taurus, and I showed him what normal atmospheric pressure was. We removed the cap. It was still reading 4.18 volts. Then he tells me that a few years ago they had replaced the fuel pump. And on this Mustang, that means pulling it down, pulling the tank down, putting it in, and also exposing the plastic lines to whatever damage there could be. So that's in my mind. And we're in my driveway. I'm not going to jack this car up and lower his tank. Don't do that here at home. But I said to him, I said, Butch, I said, you're working for a school district. They have a lift in your maintenance shop. Take it back up there. I'm pretty sure you're going to need a EVAP pressure sensor. The hardest part was finding one because it's the one with the plastic hoses. He finally found one, put it up in the air, and I said, I want you to lower it down, and I want you to take the voltage readings right at the sensor. So he did, and the readings were the same. I said, I want you to visually inspect the lines, make sure that those plastic lines didn't get damaged when you did the fuel tank, whatever, just do a good visual inspection on it. Then I want you to go ahead and disconnect that sensor, and he didn't record it. He got 5 volts, so we knew the circuit was open. So then he went ahead and took the new sensor and he plugged it in, and bingo. He's down to 2.68 volts on the scanner. And I know that looks like a doctored picture on the right with the meter, but the picture he sent me was not real clear. So I took the 2.66 volts that were on the screen and I overlaid it with a voltage so you could see it. But my point here being, the car is fixed. No restrictions. Sensor's back to where it needs to be. So he tells me it's all done. And then the next day he says, hey, Rick, car's run all its monitor tests. He had a little handheld scanner I gave him. And look at what we got here. After 3.5 years, all these sites, I'm going to show you the invoice or the list the wife made. Test complete, test complete. The only one that's not complete is EVAP. And I said, don't worry about that, Butch. It's going to run. And we were coming back from Tahoe. We swung by his house. I took these readings, verified everything was good, and told him, hey, just drive it. EVAP's going to run even though you don't need it to pass the test. Well, EVAP ran. He ran a smog. And then this is why we're sitting at the house. Here's the wife's detailed list of things that had been done. Detailed to a point. Didn't itemize all the items, but this is where she had been over the years trying to get this car to pass. Now we're up at $4,400 for this car. And one of the cats that was replaced, when we got done with this, if it was a Mode 6 class, I'd show you. They didn't understand Mode 6, and they saw the numbers and thought the cats were bad, and it was a default value that Ford put in. And when we got done testing this, both cats were good, and the old cat had 100-something thousand miles on it, were almost as good as the new cat. So you can see by not doing due diligence of checking the PIDs before you start doing your work, thinking about that list that I had there, this caused a lot of heartache for her. She's so happy. She was the original owner. It's a Mustang convertible. She loves it. She's still driving it and happy as could be. So I can't say it was misdiagnosis because I don't know what all these repairs were, but had this been checked out with the way I teach you to do it, this would have been identified up front. If it was a can car, it should be much more noticeable because the EVAP PID is on the global list. And something that's not thought about a lot, but it is a blocker, and it prevented all the monitor tests from running. And we're going to get in the FTP here a little bit more shortly. It is a blocker, can be a blocker, and in this case, it was a 3.5-year blocker that cost her a lot of money. So could she have saved $300 for that? Yeah. So something to think about. Okay, I like to use the word perform driver's seat diagnostics. I'm a believer in that. Start from the seat of your pants. You got a scanner in your hand. Should take you 5 minutes to do what you got to do. I do this with a number of systems. Some take longer, especially if you're going to do a topology check of the network. Might take longer. But the point here being is there's things you do with the driver's seat. That's where you started. Your scan tool gave you you're getting the clue out of the scan tool. And it says identify the DTC and what is normal. So if I go here and it says, I like to call it sequence of events. Everything we do in automotive is a sequence. I don't care if it's ignition system, fuel system, there's a sequence to everything. And it says, what brought the customer into the shop? The mill was on. Well, I'm being generous with that statement because we know if the mill's on and the car doesn't change how it runs, a lot of them don't do anything about it. But we do know that if the mill's on, there's a DTC is present. Simple as that. What sequence of events did the PCM follow to lead us into the customer into the shop? Well, very simply, the mill's illuminate, and this happened because one or more monitor tests ran and completed testing, and they failed. That's the simple process. Remember, this is all thought process to begin with. What do I do next? Don't touch anything. I've seen guys go and crank on gas caps, tug on lines. You're getting paid your diagnostic hour for this. Do it. Don't touch anything. Test is received and find the problem from there. Because if you turn that cap and you tell the customer, oh, I think that was it, and you charge them anything, they're going to own you because they're going to figure, you told me it was fixed. Now I got to come back, and are you going to do this for free? So the idea on EVAP, since it can be such difficult problems to find sometimes, as small problems, don't touch anything. And a good rule of thumb is what a good friend of mine used to post everywhere. And we used to have at the college, you even put it in the bathroom so the guys would hit the toilet instead of the wall. It says, Doug's first 4 rules. Engage brain before hands. Check the basics. Check the basics. Please check the basics. And the basics of EVAP, very simply, or any system, I like to call it vector. Verify, examine, confirm, test, organize your test results, repair, rebuild, road test. We don't do much rebuilding anymore, but I think this is a good concept that applies to every system out there. Verify what the problem is. Customer's concern. Look for the obvious. We're going to get into that with EVAP. Confirm that the problem exists, because if it's not broken now, we may not be able to fix it right now. Test the system with whatever equipment. Scan tool first, then we might go to a smoke machine or we might go to a multimeter. But don't do the scan. Don't go to the smoke first, and I'll show you an example of that. Organize all your test results. Now plan your repair. And if you follow these things, we're doing great. Okay? And again, broke it down into this little chart right here. I added a slide, so I forgot to take one out. Sorry about that, but there it is right there. Okay, verify the reporting component. This is critical. If I asked you, everybody in this group, how many of you, what is the reporting component for the catalytic converter, you'd all tell me the front and rear O2s. Well, they got to be functional to a point to be able to test the cap. For EVAP, it's the fuel tank pressure sensor, the reed switch in the LDP, the NVLD, there's a switch in there. The eSIM that Chrysler uses, there's a switch in there. We also have a motor that Bosch used for a while in the DMTL. We got to make sure those are working correctly, because if they're not, they can lead us down the wrong path if they're reporting the wrong results. Look at that Ford, 4.18 volt. It didn't flag a code. It blocked the other monitor test. So it's important we know good, and that we need, the PCM does not do a rationality check on the FTP, but we'll see it does do it on the reed switch on the LDP. So we'll take a look at that. No known good values, and I'm going to give you some of those in a little bit. FTPs can be almost anywhere. The way thing to remember about them is they're basically pressure differential sensors, atmospheric on one side, fuel tank pressure on the other side, and the difference is a vacuum. Simple as that. That vent port has got to stay open. They get plugged. There can be your problem of getting a stuck diaphragm because it can no longer move. The one on the right, the LDP, which has been around forever and still around, I highly recommend that. As you can see here, what's the first test they do on the LDP? They test the switch. If the integrity of the switch can't be proven at this point, they're not going to go on with their in-bay test or their monitor test to check for leaks. So that's why I say it's so critical that you check FTP switches before you start. The old DMTL that Bosch used, I basically think of it as like compression in an engine. If you have no compression, that engine freewheels. It's very little current draw. Then the EVAP, that means we got a leak. If we got a tight system, that pump has to work harder. It's going to draw a little more current, and we're going to have a leak detection off of that. It'll do a reference check and things like that, but those are the main methods we have out there. Whether it's an ESIM switch or an LNB-LD switch, which unfortunately they don't check just to check, you have to do the checks on them. Nominal values, this isn't all of them, but I want to show you a few pretty standard. You can see a lot of the number of products. This would have been the ideal in the EVAP world. 2.5 volts, that's where we would have started everybody. Positive would have been pressure, negative would have been vacuum. But then GM came along and said, we're going to move 2 wires in that sensor, and we're going to do the opposite. We're going to make it 1.5 volts at sea level, up as vacuum, down as voltage, and people need to be aware of that. Ford, pretty consistent, 2.6 volts at sea level. Toyota had a couple different ones. You had to read voltage on their systems. 3.3 volts, this was taken directly from the sensor. Their newer pump systems were around 4.1 volt, and you can see Nissan had 2 generations of FTPs, depending on the car they had, whether it was a split system or it was a one system. We're going to look at that next month when we do monitor tests and show you how those 2 different systems work. And we could go on and on. The nominal would be this, but it's not an absolute. So these are a little bit of the variables that you're going to see out there, but you got to know good to know bad. NVLD switches, there's a check being done on the switch that it closed. You can do it through vacuum. You can seal the system, do it through vacuum. Some of the smoke machines have actually a vacuum line on it. You don't want to draw it down too much, but you want to know the switch work. You can get to the unit itself. You can draw a vacuum on it, know that that switch is working. Remember, that is the reporting component. And if it's not reporting correctly, you're either not going to get the test run or you're going to have other issues. Okay, so taking a look at that. Now, what I like to do to verify FTP, I told you about driver seat diagnostics. Hook up your scan tool, whichever side you got to be on, depending on the year of the car, global or OE, and go into your pressure sensor and take the engine and look at the nominal, key on engine off. This is a GM 1.4 is just a little bit of a pressure, not much, minimal. Then I want to take that thing and I want to rev it up to 2,500 RPM and I want to see what happens. I see the command is there. I see the fuel tank pressure sensor now has gone up to 2 volts, so I know I'm pulling a vacuum on it. And here I am pulling minus 5.6 and this says millimeters of mercury. But point here being is, and I'm not even sure that value is right on that car because GM typically is always inches. That looks like water column to me. Oh, it does say I got it blocked out under the lot. It is inches of water column. Okay, now how can we draw a vacuum on the tank when the vent is open? Always remember this. Your canister in the system is a restriction. That will naturally pull a vacuum. If you know your purge is open and that number isn't increasing, check to see if that canister is depleted. There's no restriction there. But if it's there, you should be able to draw a small amount of vacuum. 3, 4, I've seen 7, 8 inches, but typically in the 5 range is a good average. So that's all driver seat diagnostics. It takes just a couple minutes at 2,000 RPM, wherever you can see this data. If you can see it on the global, you can see the purge, and you can see the FTP, you don't need to go to OE. But if you have to go over the OE, then this is the kind of thing you want to look for. That can really help yourself speed up your diagnostics. Remember, we want to check the reporting component first. Now here's one. It's a Nissan Rogue 2018. Revving it up. You can see the command is there. Now, obviously we don't see any pressure change. So the question becomes, is the solenoid defective? Is there a blockage? What's going on here? Well, we got to be careful of our tool, and we got to also understand our unit value when it comes to the FTP. So I know there's nothing wrong with this car. I say, this one I'm first looking at Global OBD2 with Pascals, and I'm thinking, okay, what could I do to make this better? So I'm going to go over the OE side, same car, and watch what happens here. There's my purge control. There's my vapor pressure sensor and voltage. Much more responsive, much more definitive that it's working. Same car, but by understanding what you're working on and going over the OE side in this case, I'm seeing beautifully that there's nothing wrong with this car, and that is just the way it is. Now, had I pulled this thing in down to a much more serious vacuum, would I have possibly seen some change? Yeah. And I didn't really run this the same way, but you could see right in here, we should have pulled it. Should have pulled the same thing right here. Not happening. Pascals versus kilopascals, big difference. Okay? Now, when it comes to DTCs, this is why you do your rationality check. FTP is nothing more than a 3-wire circuit, 5-volt signal ground. PCM only looks at the FTP for opens and shorts. It doesn't do a rationality check to say, oh, is that thing stuck at 4.18 volts? Is it stuck at 1 volt? We're going to flag it. It doesn't do that. It garbage in, garbage out. And typically I use the range of about 0.2 to 4.8 volts. And you can see that Ford we had, 4.18 volts would have been in this window. With a PCM would have just said, hey, we're not going to run these tests because we're seeing excessive pressure in the tank, but we're not going to set a code. It doesn't say, oh, there's a bad FTP, so go fix it. So we need to be aware that with the FTP, you got to know what you're doing and you got to do your testing. System inspection. Once you get beyond that point, start looking for fittings, clamps, rust. Obviously in California, unless you're up in the snow countries of California, you're not going to deal with the rust so much. Or if you live near the Pacific Ocean, maybe. But look for any signs of anything that could have damaged it from the environment. Make sure connections are good. Just do a good visual inspection of the system as best you can. Make sure nothing's been eaten on the wires. We all know about that. So a good visual. This is all quick stuff once you're there. And here's an example of a BMW we had. Got leak check. Well, first of all, we did our visual, and you can see the vapor separator has never been put back to where it was supposed to be. Had some work done on it. Not even fastened in. And then eventually what happened is a hole in the hose. Somebody had been working on this car, and it's proven by this 18 millimeter snap-on wrench right here that was pressed between the chassis and the body. And I told them, we'll fix all. We diagnosed all this. You can take this home, pull the chassis down, and you can get it out yourself because that shouldn't be in there. But a good visual inspection, start before you blow. I don't need to blow smoke here. I can see what's going on. I can see that up front. So look at who's been in there. If anybody's been messing with it, good one here. Okay, this is one I just got a couple weeks ago. I help people remotely in the sense of I get a lot of messages, texts and former students that say, hey, I need some help. And this was a good friend of mine, student I've known since '86. Recently received a text from him and some pictures he sent me. The vehicle is reporting a P0441 flow issue and a 455 leak issue. It's a 2011 Tundra with a pump. He tells me the purge valve checks out okay. And I'm saying, okay, well, how did you do it? And he said, well, I duty cycled and everything. I said, okay, well, let's hold off on that right now. But he tells me, too, that it's smoked it and there's no leaks. So I'm thinking, okay, the leak purge is at least closed. So that might explain the flow problem if it's not opening. But what about the leak code? That's where we're concerned. So he's really into this, and this is what I get. I get Mode 6 information from him. It's not really doing any good for anything. It's just confirming that when I look this up on the chart, yes, it's a flow problem and it's a code problem. I don't use Mode 6 and EVAP other than to see, like on the pump system, where did the test fail. But that's about it, and I don't even usually have to do that. But here's another one, and I'll show you how these matched up. He really wanted to know how to find the TID chart. So I went into Mitchell and I sent this to him. And I said, yep, there's your PO455. That was the one that failed on the screen. And there's your 441 for your purge flow. So I'm going through this with him, and I said, do me a favor. You tell me there's no smoke. You tell me the purge is closed. You think it's closed. I said, I want you to just go ahead and take the line off of the purge, at the canister, and I want you to blow smoke from the purge or the service port into the tank. I get a call. Well, nothing came out, and he found the granulated charcoal from the broken up canister in the line. So point here is the canister was depleted. The line was plugged. The purge was good, but he did put a new purge valve on it, because anytime there's granulated charcoal in the line, you want to make sure it doesn't get up into the purge solenoid, which is fine. That was a maybe yes, maybe no type thing. But he put a purge on it, he put a canister on it. And the scary part about Toyota is everybody goes to the canister right away because it's a typical problem. But the idea is he wanted to be sure he got this one. In this case, by blowing smoke through that line, he found the blockage, and that was the reason for no purge flow, because nothing was coming through on the tank from the canister. And when he pulled the leak check, there was a restriction there, but it was not allowing the system to test properly. So this is how you can put it together. And what I did is I didn't have the canister, and he shook the canister from me on the phone. You could hear it just jingling away. That wasn't a picture of his. I had one in the memory bank. So I just wanted to remind you that anytime that granulated charcoal, and it can be a fine, it can be a pellet, if that gets in the line, you can get a restriction. I've seen them where they overfill the cars and it turns to mud, and you get the same condition where there's no flow to the back of the car, or no flow from the back of the car to the front of the car. So anytime you're doing a canister issue, make sure, and he did go out and blow the lines out, and he did make sure that, well, he put a new purge on it, but he made sure everything was clear. So important, just because it says there's a flow code and a leak code, that usually tells me that either I got an FTP that might not reporting properly, may not be reporting. And what I did tell him he could do quickly was, I knew it was a Toyota, so he could take the lines off the purge. He could just stick those two lines together quickly and look at the FTP on the tank and see if it moved. And instead of doing that, he did the smoke right away, but he could have done it either way. And if he hadn't seen that FTP went, he would have done the smoke anyway, because it would have been, did it not get to the FTP, or is the FTP on the old canister not good? So one or the other. So this was an interesting one. Don't get lost in the mode 6. That's not the issue. But the idea was, look at the codes, visualize the system, and reason it out. And with the conversations and texts I had with him, I mean, it didn't take that long for him to finally figure it out, but he didn't visualize enough to say, hey, am I getting smoked to this point? And anytime with EVAP, pinch off pliers, whatever, isolate your leak. Leak's gone here. What's on the other side of it? It's a quick way to look at it. Okay. Another Toyota we had, via PO446 vent control. And if you ever work on any of these, not uncommon, you get a 440, 441, and 446, which means throw the coins up in the air and see where they land, and then pick your choice of repair from there. But this was the older, what we call non-intrusive system. This was the 96 to 2000, some 2000, early 2001s. This was a split system. You'd either test the front side in a vacuum or the back side in a pressure, but it never combined the two. And there's a pressure sensor in the middle to split it. And I can visualize that system like the back of my hand. So I worked on so many of them. Go in here, I look at my freeze frame. Okay, closed loop, 1800 RPM, warm engine. Okay, nothing to be had there. So I went ahead and, again, visualize the system. And here's the system the way it works. When you turn the key on those older Toyotas, it reads the pressure sensor, and it's looking for vacuum on the canister side. When it energizes that solenoid, it switches over, and now it connects the tank to the vapor pressure sensor, not the two. So where we have a switching valve in the middle that literally is a switch either or, and this is where our problem is. The way we verified is, one, the mode 6 here showed a fail. In this case, I believe it. I know the system well enough. The NA was actually NA just means it's got to be a higher number. Normally on a solenoid, I'll see 255 here. That means it's either high or it's low. Well, it failed. So I looked it up, which I knew it was, but for teaching purposes, I put this in here. And again, careful on the older Toyotas. This is actually a 02, not an 82. Their literature was wrong, as you can see here. This is a 02. Their literature says 82. Canister pressure change. Canister pressure change when I switch the system right here. So when I switch this system here, whoops, I'm trying to get that to go back. Let me come into it again. There we go. When I switch this system here, that's what it's looking for. It's looking like a definitive high-low type situation. Okay? So I already know where I'm going with this thing, and I haven't left the driver's seat yet, and I haven't climbed underneath the car yet. It took longer to repair it than it did to diagnose it. So it's telling us the malfunction. It says leak. This system doesn't even check for leaks. It only checks for canister side vacuum and tank size pressure. That's it. And you see numbers like this, never use them. Okay, so decided to graft it. And one of the keys if you're going to graft solenoids like this is make sure you get all the cars off the freeway. Limit your PID list to what is important. Because the more cars in the freeway, the slower the refresh rate, the slower the graph's going to update. So in this case, you can see, and you'll see the good one here in a little bit, this is a solenoid that's supposed to be either on or off. Pretty close to what we're doing here. Notice how here sometimes it's not even pulling down all the way. So there was our sticky solenoid. Could see it right in the driver's seat. Again, I'm not into this, maybe 5 or 10 minutes at the most, but I already seeing what I want to see. So we went ahead and we replaced the FTP. That took longer than the diagnostics because if you ever done those, I was not where I had a lift, so I had to jack it up, get underneath it, get that little screw around the exhaust, and get it in and out. But first I went ahead and plugged it in, checked it out, everything was working. Then I took it for a drive, and here's what we got. We ran the monitor test on this, and you can see the definitive changes in the pressure sensor and how clean the switching on and off is on the bottom pictures compared to what we had before. Again, working with a scan tool, not a smoke machine. I know people would have spent half hour on this looking for smoke. The issue with this car is, and we're going to address this next month, is you have to drive this one quite a bit. Most EVAP monitor tests under vacuum decay systems, 5-10 minutes at the most, and 10 minutes is even pushing it. This Toyota system with the split system relies on vacuum on the canister side and pressure on the tank side. Well, I was returning this car to the person who got it to me about 40 minutes away, and this thing took about 35 minutes to complete because it was a cold morning, it was in the fall, the tank wasn't getting super hot, and it took that much time to build up enough expansion pressure in the tank for it to say, yes, we don't have a leak in the backside, we built the pressure. We don't know, they never know the size of the leak on the system, but they do know they built up pressure to a certain level, so the system's tight. And it took about 40 minutes for this to set. We'll take a look at these next month. Okay, and reran the mode 6. And just for teaching purposes, I pulled this up and I want to convince myself, there's our 255 value, which means it was seeing the proper switch. We don't even worry about converting this. Don't even get into that. This is just a clue to say, hey, we're in the ballpark of where we want to be. Okay, and then just a few other things to remember. Don't forget purge control, bidirectional test on the OE side of the scanner. I told you earlier, not only listen, feel, but if you're going to do the vent solenoid, I like to be blowing smoke so I know it's definitively shutting off. If you're used to global OBD2, there is a thing called mode 8, and mode 8 is not a bidirectional test. It works on a number of cars, but it doesn't work on all of them, and they've been trying to talk about enhancing that on the new OBD on UDS, but I don't think they're going to have any luck with that because the OEMs aren't really cooperating. What I really want to emphasize on this is, if you use this method, which does work well, best thing is to blow smoke, have mode 8, activate the test. If the ball starts to drop, you know the command was there. There was some movement in the solenoid. If it does go to the bottom, hold it there for a little bit, but don't exit the test or take your scanner off the car thinking that the test is over. This only turns it on. It doesn't turn it off. So with the smoke blowing, what I like to do, and the ball at the bottom, turn the key off. Once the PCM cycles down, you'll see it release the vent solenoid and the ball will go up. If you walk away and leave that key on and forget about it, you're going to be cooking that vent solenoid, which is going to prematurely make it fail down the road. So mode 8 when it works is great, but beware of that. Okay, I think we're right where we need to be. For any of you that have any questions, that's my email. Feel free to reach out to me. My website, I gave it to you earlier. It's there as a resource for you. I'm trying to share my years of knowledge in this industry with you at no cost, no cookies, no anything. And if you see something or you don't see something there, let me know. It just takes time to develop it and get it on the website. But for anybody, I don't know if anybody has any questions or anything out there for anybody. I really appreciate your spending time with me. And I don't know if Delphi is going to. This was recorded by Zoom. I think they're going to send it out, but I don't know if they are. If you were here and you wanted to see it, I have a recording of it, and you could email me, and I can drop it in my Dropbox and send you a link to it, or maybe drop me a note and see if you liked what's going on. I'm hoping to follow up on September 18th. The next month's tech tip for me on Thursday the 18th would be basically tips and tricks again, but running monitor tests to set the readiness flag or verify a repair. And again, for people in California, that's going to become more critical October 1st when we require all the readiness flags to be set. And it's going to be a small percentage of problems for some people. Other people that go about their business, their EVAP monitors are complete. But if they should clear the memory and have to reset those, now we could be looking at a lot of time where the customers used to get in their car back and say, hey, you're going to either go drive it or you're going to have to leave it here till we get that thing to run. So we can hit on some of those things next month. So as far as for me, if there's no questions, if anybody had one, I can open a mic and answer a question. But let me know. So other than that, I thank you for attending, and I see my good friend Scott Brown has joined us. And I hope that you guys got something out of this short Thursday Delphi tips and tricks to help you out there. So I look forward to seeing you maybe next month when we do a follow-up to this. Other than that, we can sign off and call it a day. And I thank you. Alan, are you okay? Did you have any questions?
No, it was very informative. Thanks, Rick.
Okay, good. I just saw you were still there, and I thought I'd ask. They have their system of turning everything off, and I like the interactive stuff. But
Mhm.
if you got anything out of it, or if you want a link to this, you can email me, and I send you a link to it when I put it on my Dropbox. And if there's anything you missed and want to look at it again, feel free.
Cool. Thank you, sir.
Okay, take care, buddy.
Bye.
Bye.